Picture this. Your child sits quietly in front of a screen, watching what appears to be innocent cartoons featuring beloved characters like Elsa from Frozen or Spider-Man. The bright colors and familiar faces seem harmless enough. But as the autoplay feature clicks from one video to the next, something concerning begins to unfold. The characters you thought you knew start appearing in increasingly inappropriate scenarios, content that doesn't match what you'd expect from legitimate children's entertainment. This wasn't the work of a single rogue creator or an isolated incident. This was the result of YouTube's own recommendation algorithm, systematically serving inappropriate content to the platform's most vulnerable users: children. For years, an entire ecosystem of problematic content operated in plain sight, hidden behind bright thumbnails and familiar characters. Welcome to Vanishing Threads, where we unravel the internet's most disturbing mysteries and digital anomalies. Today, we're exploring how YouTube's recommendation system created one of the internet's most concerning phenomena: the algorithmic rabbit hole that gave birth to Elsagate and exposed significant flaws in content moderation for children. To understand how this situation developed, we must first examine the machine that made it possible. YouTube's recommendation algorithm, launched in 2012, was designed as an advancement in personalized content delivery. Its mission was simple: analyze user behavior, predict preferences, and keep viewers engaged for as long as possible. The algorithm processes billions of data points every second. It tracked what you watched, how long you watched it, what you liked, what you shared, even how quickly you clicked away. This system was designed to create a personalized viewing experience, serving up content based on your viewing history and preferences. For most users, this system worked as intended. Watch a cooking tutorial and your homepage would fill with recipe videos and culinary content. Express interest in astronomy and you'd see documentaries and educational content about space. But children, who often watched passively, clicking on whatever appeared next, became unintended test subjects in an experiment that would reveal significant problems with the algorithm's approach to content recommendation. The year 2017 marked a turning point in our understanding of algorithmic content recommendation. Parents around the world began noticing something concerning about their children's viewing habits. What started as searches for nursery rhymes and cartoon characters was leading to content that was inappropriate for young viewers. Videos that appeared to exploit familiar characters for unclear purposes. The term Elsagate emerged from Reddit, coined by users who had discovered a network of channels producing content that misused popular children's characters. The name referenced Elsa, the Disney princess, who frequently appeared in this problematic content. The subreddit soon became a central hub for documenting this phenomenon, and what the community uncovered was significant in scope. Thousands of channels were producing millions of videos, all optimized to exploit YouTube's algorithm and target children with inappropriate content. These weren't random uploads. They followed systematic patterns that suggested coordinated efforts to game the recommendation system. The creators behind Elsagate had reverse-engineered YouTube's recommendation system to their advantage. Dr. James Bridle, whose investigation into this phenomenon became widely referenced, termed it algorithmic exploitation, the deliberate manipulation of machine learning systems for profit. The process was methodical. Content creators would identify trending keywords and popular characters, then mass-produce videos combining these elements in ways that violated content policies. The algorithm, designed to promote engagement, began recommending these videos to children who had watched legitimate content featuring the same characters. The operation required understanding viewing patterns of children, identifying what captured their attention, and then creating content specifically designed to exploit those patterns. These creators were operating what amounted to content farms focused on children's content. The videos followed predictable patterns: bright saturated colors designed to catch attention, familiar characters that would inspire recognition, titles packed with popular keywords to ensure maximum visibility in search results, and content that pushed boundaries while staying just within what might avoid immediate detection. YouTube's autoplay feature became a key vector for this problematic content. Children would begin their viewing session with legitimate content like a Peppa Pig episode or Disney song, but within minutes, the algorithm's recommendations could lead them to inappropriate content featuring the same characters. The system's apparent randomness made it difficult for parents to detect. A quick glance might show familiar characters on screen without revealing that these characters were being used in inappropriate scenarios. The autoplay function created an automated pathway from legitimate to problematic content. Each click was automatic, each transition seamless, guided by an algorithm that prioritized engagement metrics over content appropriateness. When journalists Max Fisher and Amanda Taub of the New York Times investigated Elsagate in 2017, they uncovered a phenomenon of significant scale. Some of the most popular channels had accumulated billions of views. One channel, Toy Family, had amassed over 8 billion views before being terminated. The financial incentives were substantial. YouTube's monetization system, which pays creators based on views and watch time, had created an economy where inappropriate children's content could be highly profitable. Estimates suggested that the most successful Elsagate channels were generating hundreds of thousands of dollars per month. Dr. Alexis Heineker's research at the University of Washington documented the scope of exposure. Her study, published in the Proceedings of the ACM on interactive, mobile, wearable, and ubiquitous technologies, found that children as young as 3 were being exposed to this content. The algorithm's recommendation system was particularly effective at capturing and holding children's attention for extended periods. The algorithm, designed to maximize engagement, had learned that certain types of content featuring familiar characters were effective at keeping children watching, regardless of the content's appropriateness. As investigators examined the Elsagate ecosystem more closely, they discovered that many channels weren't using traditional human creators. Instead, they employed automated systems to generate content at industrial scale, producing far more videos than human creators could match. These automated systems could produce dozens of videos per day, each following similar templates. The content was often repetitive and nonsensical, featuring random combinations of popular characters in scenarios that seemed designed more for algorithmic consumption than human viewing. Videos typically featured repetitive actions, bright flashing colors, and jarring sound effects, all elements that the algorithm interpreted as engaging content. This created a feedback loop where automated content was optimized for algorithmic recommendation rather than human entertainment. Reddit investigators documented hundreds of these channels, noting how they often used similar naming conventions, thumbnail designs, and content structures. The investigation revealed networks of interconnected channels that appeared to be operated by the same entities, creating an ecosystem of algorithmic manipulation. These systems appeared to be learning and adapting. Each successful video provided data about what captured children's attention, creating increasingly sophisticated approaches to content creation that adapted faster than human oversight could respond. Initially, YouTube's response to the growing concerns was slow and inconsistent. The company maintained that its community guidelines prohibited inappropriate content targeting children, but enforcement was uneven. Many channels continued operating for months after being reported by concerned parents and researchers. The platform's approach revealed challenges in content moderation at scale. YouTube had built a system that could process and recommend billions of videos, but struggled to effectively identify content that was inappropriate for children. The turning point came from financial pressure rather than content concerns. In November 2017, major advertisers began pulling their campaigns from YouTube after discovering their ads were appearing alongside Elsagate content. Companies like Mars, Adidas, and Deutsche Bank suspended their YouTube advertising, costing the platform significant revenue. This advertiser exodus prompted swift action. The company announced several policy changes that altered how content targeting children was handled on the platform. Stricter enforcement of community guidelines for content featuring minors became standard. Channels that inappropriately exploited children's characters faced demonetization. Enhanced machine learning systems were deployed to detect and remove problematic content. The introduction of YouTube Kids as a separate, more heavily moderated platform, acknowledged that the main platform had failed to adequately protect young viewers. By early 2018, YouTube had removed thousands of channels and millions of videos associated with Elsagate. However, critics argued that the platform's reactive approach had allowed the problem to persist for too long, potentially affecting millions of children worldwide. The Elsagate phenomenon revealed significant issues with how algorithmic recommendation systems operate, particularly regarding vulnerable users like children. The incident highlighted how systems designed to maximize engagement can be exploited in unintended ways. Dr. Zeynep Tufekci, a researcher at the University of North Carolina, argued in her 2018 TED Talk that YouTube's algorithm doesn't just reflect user preferences, it actively shapes them. For children who are particularly susceptible to algorithmic influence, this can have significant psychological effects. The phenomenon raised important questions about the responsibility of tech platforms to protect users from harmful content. While YouTube argued that manual review of every uploaded video was impossible, critics pointed out that the company's own algorithm was actively promoting the problematic content. The incident became a case study in how artificial intelligence systems can develop behaviors that are technically successful but ethically problematic. The algorithm had learned to optimize for engagement without considering the appropriateness of that engagement. Although YouTube's crackdown significantly reduced the prevalence of Elsagate content, the phenomenon's impact continues to influence digital safety discussions. Researchers have documented effects on children who were exposed to the content, including increased anxiety, sleep disturbances, and inappropriate behavior. The incident sparked broader conversations about digital literacy and parental supervision of online content. Many parents reported feeling their trust in the platform had been violated, having relied on it to provide appropriate content for their children. Elsagate demonstrated how algorithmic systems could be exploited to target vulnerable populations. The techniques used by Elsagate creators, keyword stuffing, thumbnail optimization, and engagement manipulation, have since been adopted by other forms of problematic content across various platforms. The phenomenon served as a significant learning experience for the tech industry, regulators, and society. It revealed that algorithmic automation, while powerful, requires careful consideration of unintended consequences, particularly when it affects vulnerable populations. Years after the height of the Elsagate crisis, important questions remain. How many children were affected by this content? What are the long-term impacts of exposure to inappropriate algorithmic content? And how can similar exploitation be prevented in the future? The incident raises ongoing questions about artificial intelligence and machine learning. How do we ensure that systems optimizing for engagement don't compromise user safety? How can we balance algorithmic efficiency with appropriate content moderation? The Elsagate phenomenon represents more than a content moderation failure. It's a case study in the unintended consequences of algorithmic automation and the responsibility that comes with creating systems that influence human behavior at scale. The YouTube algorithm rabbit hole represents a significant example of how technology designed to serve users can be exploited to target vulnerable populations. What began as an attempt to create personalized viewing experiences became a system that could be manipulated to serve inappropriate content to children at scale. The Elsagate phenomenon serves as an important reminder that algorithmic systems require ongoing oversight and consideration of their impact on all users, particularly the most vulnerable. It challenges us to think critically about the technology we use and to demand appropriate protections for those who cannot protect themselves. The algorithm was designed to show us what we wanted to see. For millions of children, it showed them something inappropriate. And our understanding of digital safety and algorithmic responsibility has been shaped by this experience ever since. As we continue to rely on automated systems to curate our digital experiences, the lessons learned from this incident become increasingly important. Effective algorithmic systems require not just technical sophistication, but also ethical consideration and appropriate safeguards. If this story has raised questions for you about digital safety, algorithmic manipulation, or the broader implications of automated content curation, I encourage you to explore the extensive research and documentation linked in the description below. The Elsagate community archives, academic studies, and investigative journalism referenced here provide deeper insights into how these systems work and what we can do to protect ourselves and our families in an increasingly algorithmic world. The threads of this digital mystery continue to unravel, and understanding them is the first step toward ensuring they don't entangle the next generation. Thanks for tuning in, and until next time, stay curious, stay safe,